Chapter 12, Part 2, Solids, Density. So the main idea in this part is to introduce a new quantity called density. What is density? Density is a property of a material, and the density of a material depends upon the masses of the atoms that make up this material and on the spacing between those atoms. So, again, density is one of the properties of solids, as well as liquids and even gases. It measures how tightly the material is packed together. Mathematically, we can say that density, it measures how much mass occupies a given space. It is the amount of mass per unit volume. So you can write density is equal to mass over volume over size. Mass per unit volume, that's called density. Now you can check the units of density easily by looking at the equation. Mass is measured in kilograms or grams, and volume we measure it in meter cube or centimeter cube. So there are two units we could use, either kilogram per meter cube or gram per centimeter cube. Now to relate the two units easily, we say that 1 gram per centimeter cube is equivalent to 1,000 kilogram per meter cube. Let's look at this example. If you have a loaf of bread and you squeeze it, what happened to the density? Well, if you squeeze a loaf of bread, then this means the volume will decrease. If you go back to the mathematical equation, if you squeeze the loaf of bread, the mass wouldn't change, but the volume will change. The volume becomes smaller, so the density becomes bigger. Why? Because as you look at the equation, density and volume are inversely proportional. Inversely means when the volume becomes small, density becomes big. When volume becomes big, density becomes small. So those are called related by saying they are inversely proportional. If you look at density and mass, those are directly proportional. So this means if the mass becomes bigger, the density becomes bigger. So in this problem or this question, as the volume decreases, the density will increase. So density is a property of material. But why is it important? Because it's a property. It doesn't matter how much you have of the material. For example, if you have a pure iron nail, it will have the same density as a pure iron frying pan, for example, because the same material. So same material will always have the same density. So the mass per unit volume, that's the density for the iron nail, and the density for the iron frying pan is the same, because the key point is that it's the same material. Iridium, that's one of the elements in the periodic table, one of the atoms. It is the densest substance on Earth. It has the highest density. Now, you may try to understand why. In fact, iridium atoms are less massive than, for example, gold or mercury or uranium. But because they are closely packed, because the distance between these atoms are so small that its density is very high. In fact, it is the highest density. A cubic centimeter, just 1 cube centimeter of iridium element contains more atoms than a cubic centimeter, let's say, of gold. That's how because the iridium atoms are very closely packed together. Now we have this table. You can look at the table, and here you can see different elements, and for each element we have the density. Of course, the density here is given in units of gram per centimeter cube. We are not required to memorize these numbers, but I want you to look and to try to compare and think. First, you can see that iridium has the highest density. Its density is 22.6 gram per centimeter cube. Now, what is the meaning of this number? It means that if you have 1 cubic centimeter of iridium, there will be 22.6 gram. So 22.6 gram in a centimeter cube. If you compare this to gold, gold has density of 19.3 gram per centimeter cube. Look at iron. Iron has 7.8 gram per centimeter cube, much less than gold. Let's look at this important material, ice. Ice is just a solid water, and if you look at the density of ice, it's 0.92 gram per centimeter cube. Let's compare this with fresh water. Water at 4 degrees Celsius has the density of 1 gram per centimeter cube. Now, the density of water, liquid water, at 4 degrees Celsius is a little bit higher than the density of ice. Mercury has a density of 13.6 gram per centimeter cube. Now, students are not required to memorize these numbers, but let's look and let's always try to memorize at least this one. Water at 4 degrees Celsius has a density of 1 gram per centimeter cube. If you look at seawater above, just above water, the density is slightly higher. And I hope you understand. I can explain that. Well, in fact, density of a material could change depending on temperature, pressure. So in that table, you just saw, the densities are listed or are given at 0 degrees Celsius and at atmospheric pressure, except for water, which was given at 4 degrees Celsius. So water at 4 degrees Celsius has a density of 1 gram per centimeter cube, or 1,000 kilogram per meter cube. This is a famous number. A gold brick, for example, will have a density of 19.3 gram per centimeter cube, which means it is 19.3 times more massive than an equal volume of water. So if you have water of a given volume and you have gold of the same volume, gold will be heavier by 19.3 times. I have two questions here. Let's try to answer the first question. Which has more density, 1 kilogram of water or 10 kilograms of water? Think about it. Once you answer this question, try the next one. Again, which has greater density, 5 kilograms of lead or 5 kilograms of aluminum? Two different materials. Well, the first question, 1 kilogram of water or 10 kilograms of water, should be easy for us to answer. The density of any amount of water at 4 degrees Celsius is always 1 gram per centimeter cube. So it doesn't matter if you have 1 kilogram of water or 10 kilograms of water, they all will have the same density. That's 1 gram per centimeter cube. For the second question, lead or aluminum, well, you have to just go and check the table. Once you check the table, you will see that any amount of lead always having greater density than any amount of aluminum. We finish this part by the question, what determines the density of a material? We'll discuss this again in class.